That is the setting for a question. That's set hypothesis. And that's the formula for, using the x bar, and the x bar is 14 minus the null is 12, and divided by 5, and then divided by 6, because it's a square root of 36. So here is 2, that is 5 divided by, it's like a 12 divided by 5, this is 2.4, I think it is, right? Because it's 2, it's 10, 10, 20, 24, 2.4. And the 2.4, when we compare this to 196, we see that is going to be in that area. So, because it's larger than 196, the conclusion should, now the test is conclusion is reject the null hypothesis, right? Just reject the null hypothesis. The value is beyond this point, so you should reject the null hypothesis. Whatever it is, reference to the hypothesis, you need to explain what that means in terms of rejection. In that case, you may be supporting, a claim that tell you that the mean is not anymore 12, then you supported the claim, or you may have no sufficient evidence to support the claim, because you need to reject this one. Okay, that is the case of when sigma is none. If sigma is not none, then you need to go and do the case number 2, and let's say in that case we want to use I want to use the same value just to do the computation, but let's say I want to use the sample standard deviation instead of the population standard deviation. N is 36, and the x bar is going to be exactly the same, just to do the computation. But now, instead of using z values, you need to use t values. So the t values are values that we need to compute from the table, and in that case, you need to go to the table. Or you may try also to use the CDF for T in your calculator. Sometimes that works too. In that case, we know already the area, which is 0.025, and then 0.025. So you need to check if you have inverse T in your table and your calculator. If you have the inverse T, you can just read the value of T. For that case, you enter the area, you get the value, you enter actually you need to enter the degree of freedom first, degree of freedom, then the area, and then you compute this one. That is for T. Usually the calculator, there are new calculators, you should have the function in the same place that you have the distributions. Let's check if that is new, or you can go and outdate that one on the website. You can download it also. You can update your calculator. That one, the one that we use in class, that one is not updated, I guess, because let me check. Here it is not right. It's the inverse normal, but it's no inverse T. You may check yours to see if you have a T on the. Well, if you don't have T, you may use a table, and that is exactly the same thing. We use the table, and let me get a table. Where's my table right here? Okay. Okay, and our table is for 35 degree of freedom, 35. So you don't have 35, you can use 36 also, like approximation to T. Here is T, let's see, you got 35, well, you don't have 36. I mean 35, you can use 36. Because you're using alpha 5, you want to use the column number 3, the third column, and then you go to alpha 36, 31, 166, 2.028 is the value. So here is 2.28, you enter and degree of freedom, 2036. So we're here. Okay, and then you go to 2.028 minus 2.028. Okay, those are the critical values. That's the region to reject the null hypothesis. We reject there. Then we compute if you have the t-value from the sample is equal to x bar minus mu s divided by n. Actually, that value is going to be exactly the value that we computed before because we have the same values, but the t-value is different. Okay, it's going to be equal to 2.4. So for ts is equal to 2.4, and you enter that value here again. For that one also is 2.4, so 2.4 is greater than the t-value of the table. So the conclusion is you need to reject the null hypothesis too, because it is, E falls in this area, and that's area for reject. It's more than this point here. Well, that's using the critical values. If we use the p-value approach, so we need to take this value here, we need to compute the probability that z be greater than 2.4 and the probability that t be greater than 2.4. Well, that one has no problem because we can use the calculator to do it using the CDF. Let me see if the normal CDF on the calculator, or you can use the table also to do it. And using the normal CDF, let's see, I have 2.4 to let's say 4, this is the maximum value there, and then you have the one. Then you multiply this one by 2 because you have 2 sections, and you need to get the p-value multiplied by 2 is 0.01. 0.01 is the p-value here. The p-value is that case because we're using 2 tails. So the p-value is 2 times the p-value is less than equal to alpha, and then you see that one is 0.01, and that one is less than 0.05. So conclusion, we reject the null hypothesis because that's true, right? That is less than 0.05, that one is 0.01, which is less than 0.05. Again, we reject the null hypothesis because if the p-value is less than equal to alpha, we reject the null hypothesis. Otherwise, we fail. The test fails to reject the null hypothesis. The second case is for t. So we need to compute the t-value. What is the probability to observe a t-value larger than 2.4? 2.4. And one way to do it is just using, using the CDF. The values are not exactly the value that we should have, but we can try. Just let me see. Let me clear this one. We can go to distribution and normal. What is the CDF TCDF, right? And you enter, and then you enter the area, the lower, the upper, and the lower could be 2.4, and then the lower could be, in that case, I can use 10 if I want to, and that 35 is 34, 35. Gives you freedom. And let's see what happens. Okay, that is the area, okay? So you can compute, use area using the t-value, the CDF. That t-value is, let's tell you how to do. For CDF, you need to define the lower, the upper, and the degree of freedom. And then you go through this, right? You got this value. That could be one way too. Again, that is 0.001, 09. Multiply by 2, that's going to be like a 0.002, 18. So that also is less than 0.05. So the conclusion is still reject the null hypothesis like the one that we have in the first analysis for critical values. Is that clear, right? So you need to multiply by 2 because it's you using 2 tails, right? And that is the way we compute the CDF. That's the p-value. Those are the p-values. And the conclusion should be the same, right? Conclusion should be same conclusion. All right, so that is for the mean. So you have 2 cases. If you know the standard deviation, population standard deviation, we use Z. If we don't know population standard deviation, we use T. And that is just the case for hypothesis testing for the mean. You see the procedure is exactly the same but before that we did for proportion. Set out the hypothesis, you go and do the analysis. And you need to know how to use the tables, actually. The next table is going to be the chi-square table, which is the one that we use for standard deviation. And that one also is very, very easy too. Chi-square. And the chi-squares for standard deviation, we're going to do the same thing. Let's assume that we have of course, we need to do the word problem, so you need to how to get the data and how to organize your data. Well, here is the first step. Let's assume you have sigma equal 5. Sigma is greater than 5. Just make it 1 for greater than 5. Okay. And you need to test that claim that the sigma is greater than 5. So that one is the case, the region. So we have a chi-square over here. That is given the section, the rejection region over here. And that is, we take a sample of 25 and the standard deviation in that one was 6. Let's see, okay? Just for example, 6. So we have that claim, this hypothesis, we have the setting, we know we need to get the chi-square. So here is the first, for the chi-square, that is alpha. Alpha is 0.5%, right? So that one is chi-square of 24 and 0.05. Okay, so that's the one we want to look here, 24, and then you read 0.05 is about 34 That one is 34, 41. 34 of 36. 36. 36, 41. So that is the limit. And the one that we compute from the sample is n minus 1 s squared sigma squared according to the the null hypothesis. Okay. And then is chi-squared is 24 that multiply 5 squared that divides 6 squared. And that is the value for chi-squares. So, and that chi-squared, let's do it. That operation is using the calculator. So we have 24 times 5 squared divided by 6 squared. Oh, doing nothing here. 24 times 5 squared divided by 6 squared. That's 16.6. 16.6. So just if you read, then we know that is a value that is before 36, so it's going to be here, so 16.6. So the conclusion is the test fails to reject the null hypothesis. Okay, the test fails to reject the null hypothesis. It's all right. So that is just the test. The p-value in this case is a little bit more complicated, but we can try also is to do it. In some cases, if you have 16, so what we need to know for the p-value is what is the probability that a chi-squared, using that degree of freedom, 24 degree of freedom, a chi-squared is 24 and 5%, well, actually, that's what are we looking for? We're looking for the alpha value. Is greater than 16.6. So we need to know that probability right there. What is the probability, right? Okay. So to know the probability, first we need to go back to the row for degree of freedom 24, and then which one is the value closest to 16. Until here, you have 90. So 16 is more than 90. I mean, here. So you need to pass from here to here. And you see then, from 15, you jump to 33. So it's not 90, but it's 10. It could be more than, at least about 10, right? There should be something there. So that tells you that it's very large. It's a large one. It's an approximation, of course. Let me just check the value again. 24. And then I'd say, okay, it's here, at that point. In this point, the alpha value could be around 10, very close to 10. Okay? 10 is very large. It's a double to 0.05. So that means we were doing what? We failed to reject. Okay? Because if the p-value is less than alpha, we reject. But if the p-value is larger than alpha, the test fails to reject the null hypothesis. Okay, rejecting or fail to reject. In that case, we fail to reject because the value, the approximation to this value is about 0.10. Okay, it's an approximation. Or you can try also, depending on your calculators, if your calculator is a very new one, you can try to use the chi-squared CDF. And the one is right here, let me see. and the enter is chi-square CDF, like the CDF for T, CDF for chi-square. You enter the value, again, you enter the lower, the upper, so the lower value is 16.6 through, let's say 100, just to give a large value. That value you should figure out, very large value, you know, to cover all the areas. And then you enter the degree of freedom 24. That was 24 or 34? 24. 24. 24. Okay, so 24, that should be, well, they gave me something else. That is very large one. So that area is to the right. That is what the CDS computed. That means it's going to be like a 14%. That actually that is the point. Okay. Okay. If you do this to the way, okay, it's to the right. No, it's to the right. This is the point. Well, that's it. So it's for chi-square is a little bit more complicated, but that is they use the calculator, depending on the calculator. You check the calculator, see how close they're giving you the formula, the lower open. But we need to open an area so that, like before, that you know that one works using areas. So you need to define the area for the p-value, an area that is the lower, the upper, and the degree of freedom. And that should be a computation, but that is here. That one works to the right, so if the point is here, what I'll tell you is, well, that's going to give that area is going to be larger. Well, you know, here is 90 to 10, so it's getting 86. That maybe that is the right one, but that is very large because even it's not right, it's in between. So that is actually should be, you know, to identify that you should fail to reject the null hypothesis anyway. Okay, and that is the two cases that you have. Next Monday, next week, I want to do the review. The review should be on the web right now. You see it? You haven't seen it? Okay, let me check if it is on the web. That should be on the web. Should be. I'm not sure. You work on that. I think I release. We're gonna start working on. Okay, let's see. Yeah, it's open, right? I think I did it last night. Okay, that is open, so you can start working on it. See if you have any questions. The last test is very similar to that test. I want to change some figures, but that is exactly the same. I mean, the same procedures. If you know how to do that one, you may be able to happen. Don't mean allowed to go through now. Okay. Okay, is. Anyway, we should do the review on Monday. I'm going to review all the questions. What is it? Okay, that is this one. Let me check it, make sure that you have this the right one. Okay. There's a reviews here. Okay, yeah, that's the one. Okay, that's the one. Entire class. Okay, that one it has like 20 questions. see. Here we go. 20 questions, and now you need to get familiar with the wording, okay? How they present the data, how do we collect the data to do the procedure. Formulas are welcome, you can do your formulas, and you know, just a piece of paper. There is all the answers. So we're gonna meet again on Monday just to work this out and get ready for next Monday. We don't have class next Wednesday. Next Wednesday. Right? We don't have class, but we have the test after the review next Monday. Well, I remind you at the time is coming, right? Any question? Okay, that's fine. That's it for today.